Good morning, fourth grade. Happy Monday. All right, so we are going to get started. It's a new week. So today is Monday, April 6th, 2020, and our joke of the day is, what monster plays the most April Fool's jokes? Okay, ready? And the answer is Frankenstein. Like Frankenstein, but pranks. Get it? Okay. So I forgot I had that joke. Otherwise, I would have obviously used it on April Fool's Day. So we are going to go ahead and get started. We are on week 3, day 1 now. So further in that packet, I think under your science stuff maybe comes next. I'm not positive. So let's see. It looks like it's page 3 of 16, but that's not what page it is in the packet. So, okay. So under our learning targets for today, it says, I can explain the concept of fraction equivalence. All right, so remember, fraction equivalence means two fractions that are equal to each other. I can create equivalent fractions, and I can reason about fraction size and equivalence using visual models. Okay, so under that daily fluency for today, it says, what is the next step in the pattern? Describe the pattern. All right, so these were a little tricky. So if I look at the first one, I see that I have, let's see, 1, 2, 4, 7, 8, 9, 10. I have 16 squares, right, in that first shape. All right, and then when I go to the next one, I have 8 squares. Okay, then in the next one, I have 4 squares. All right, so I need to know what comes next, but I also need to figure out what the pattern is. So I'm gonna think, okay. And I'm kind of a backwards person, but if you want to start with the first one, I would say, okay, we're at 16, right? And then we need to go to 8. So what rule or what operation or what can I think of in math that would let me go from 16 to 8? All right, so I would think, okay, so I'm gonna I'll try subtraction. All right, so 16. 15, 14, 13, 12, 11, 10, 9, 8. Okay, so I would have to subtract 8 to get to 8, right? 16 minus 8 is 8. But then that means I would have to subtract 8 again. But if I subtract 8 from 8, I don't get 4, right? And 4 is what comes next in the problem. So that's not going to work. I can't subtract 8. Okay, let's go back to the beginning. So I have 16 and I need to get to 8. Okay, well, I'm going to try division. Okay, I know that 16 divided by 2 gives me 8, right? Okay, so that works. Now, if I take 8 and I divide it by 2, okay, that also gives me 4. Great. So if I take the 4 now and I divide by 2, my next pattern would be 2 squares. All right, so your next step should have been 2 squares. And then you would describe the pattern as divide by 2. Okay, that's how I figured that one out. All right, going down to the next one, it says 10,000, 1,000, 100, 10, blank. All right. So again, how can we get from 10,000 to 1,000? All right, all these numbers, they're all, multiples of 10. I'm thinking of the place value chart in my head. So I'm thinking, okay, if we go from 10,000s to thousands, 1,000, to hundreds, 100, to tens, 110, then what would come next? The next one would be ones, right? Okay, so the next step would be 1. But now, how did I get there? All right, well, if you think of that place value chart again, when you are moving to the right, right, because that's what we're doing, we're starting on the left at 10,000, and then we're going to 1,000, and then we're going to 100, and then 10. What are we doing every time we move one place to the right? We're dividing by 10, right? So you could say that the pattern here is that we are dividing by 10 each time. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. And 10 divided by 10 is 1. Okay? All right, that's my cat in the background. All right, now you have to write the rule for the following pattern for the problems listed below. We're actually just going to only do the number one. The shape one is a little weird. We'll talk about it in a minute. But so the next pattern says 216, 196, 176, 156. Okay, so let's start at the beginning and let's think. All right, if I go from 216 to 196, what am I doing there? What would I have to do to get from 216 to 196? Okay, so I thought about this for a little bit. I did some scribbling on some paper. And in order to get from 216 to 196, you would have to subtract 20. All right? So if we subtract 20, we get to 196. All right, now let's try again. If we subtract 20, all right, you should get 176. Okay, so that's working. And we'll try it again. 176 minus 20 is going to give us 156. All right, so then, all you had to do is write the rule for this one. So I know that the rule here is that we are subtracting 20 each time. All right, and then, like I said, the one on the bottom is a little tricky, even for me, honestly. I don't really know what they want you to write in some of this as the pattern. So I noticed that for each green dot, there is always, in the next one, they're adding another green dot next to it. And I noticed for the blue dots, they are adding 3 more dots to make a complete square. So I see that, right? And I can see that that keeps going, but I'm not totally sure what they're looking for in that pattern. So I'm okay if we skip that one, because remember, some of the people that put these packets together work in central office, and some of this stuff is different than the Eureka curriculum that we're using, and the stuff that we've been doing in class. So sometimes we're going to get to things and I'm just going to be like, no, let's not do that. And this is one of those things. If you figured it out, or you think that you figured it out, or have something you want to share, go ahead and email me, text me, message me on Instagram, whatever, because I would be interested to see if other people were able to come up with something like a clear pattern for that problem. Okay, so now we're going to move down to daily task. All right, so we are on task A. So task A, problem A, says the rectangle below has a length of 1. What fraction does the shaded part represent? Okay, so I went ahead and drew it here. So this is task A, part A. Okay, so let's review real quick, because we had just started really to get into fractions as this whole thing started and we had to close school. So remember, when we are looking at a tape diagram, all right, it tells me that this whole tape diagram is equal to 1. All right. Now, the number of shaded parts are going to give me my numerator in the fraction. So I'm going to say, okay, how many shaded parts do I have? I have 1, 2, 3 shaded parts. All right, so I know that 3 is going to be my numerator. How many parts do I have altogether? I have 1, 2, 3, 4 total pieces. So that's going to be my denominator, right? So this tape diagram represents the fraction 3/4. All right. Now going down to B, it says the rectangle below has the same length as the rectangle above. What fraction does the shaded part represent? Okay, so once again, I'm going to count the number of shaded pieces I have first. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded pieces. All right, and if I have 9 shaded pieces, then I have 10, 11, 12 total pieces. So this tape diagram is representing the fraction 9/12. Okay. Now, C says, use the pictures to explain why the two fractions represented above are equivalent. Okay. So I want you to look at these two tape diagrams very closely. And if you need to, under C, I want you to stop. If you weren't able to figure it out, I want you to stop and I want you to draw those two tape diagrams, but I want you to draw them very close to each other. All right. Because the point is that I want you to see how these tape diagrams really line up. All right. And how they are equivalent. Okay. So if I look here, I just drew these long lines to connect my two tape diagrams. All right. I can see that for every one piece, one unit that I have in this tape diagram, it's equal to 3 units down here, right? Here's another piece, 3 units, another piece, 3 units, another piece, 3 units. Okay. So I can see that these fractions, they're shaded in to the same part, right? They're equivalent. They just have a different number of total units. All right. So I also want you to think about, because we did get to this part, using this picture to then relate it to multiplication to find equivalent fractions, right? So if I have 3/4, and I want to know if it's equivalent to 9/12, all right, we're going to start with our denominator, and we're going to say 4 times what gives me 12? Well, 4 times 3 gives me 12. right? And that kind of relates here because we divided each of these units into 3 pieces. All right, and then whatever you do on the bottom, you have to do up top. So 3 times 3 does give us 9. So this shows that 3/4 is equal to 9/12. Okay. All right, moving down to task B. Task B shows this shape, this whatever fraction model. So part A says, what fraction of the rectangle below is shaded? All right, now, when I first saw this, I was like, what? Because normally with Eureka and, with our curriculum, it doesn't just shade in random pieces like that, but that's okay. So again, what fraction of the rectangle is shaded? So my numerator is going to be the shaded pieces. So 1, 2, 3. All right. And then remember, my denominator is going to be the total number of pieces I have. So 3, 6, 9, 12. Right? So this fraction model is showing the fraction 3/12. All right. If you go down to part B, it says, Laura says that 14 of total squares in the rectangle are shaded. Do you think she is correct? Explain why or why not by using the picture. Okay. So if you haven't answered that, go ahead and pause here. I want you to write your explanation. 2 or 3 sentences is fine. Full, complete sentences using math vocabulary, right? Fraction model, numerator, denominator, units, shaded. Okay, and then come back when you're done. All right, so explain, do you think she is correct? All right, I do not think that Laura is correct. And I don't think that she is correct because when I look at my fraction model, I can see that there are 3 pieces shaded in. And I know that the number of pieces shaded are my numerator, right? Then I'm going to say, okay, I also know that I have 12 total units in my rectangle, right? So there's no way that 14 of the total squares in the rectangle are shaded because I don't even have 14 squares to begin with. I only have 12, all right? So I do not think Laura is correct. I think that the correct answer is 3/12 because there are 3 pieces shaded and there are 12 units altogether. Okay? If you wrote something very similar to that, that's fine, as long as you really got the point that she's not correct, and she's not correct for the reasons we just talked about. All right, and then your daily closing, write a $2 or more summary of the lesson. Each word is worth 10 cents. For example, the lesson is about would be a total of 40 cents because each word is worth 10 cents and they used 4 words there. All right, so I just want a quick summary. Think about, what we talked about. This was a really short lesson today. We're barely at 13 minutes here. Think about what you know about fraction equivalence. Think about the math models that we used today. All right, what did we use today to show fraction equivalence? What did we talk about today in terms of the numerator represents what on the fraction model? So the numerator represents the shaded pieces. The denominator represents the total pieces. Yeah, feel free to scroll back through the video if you have, forgotten some of the things that this lesson was about, and just write a few short sentences that equal $2. All right. I hope you guys had a great weekend. I hope you're having a great Monday. If you complete today's work, please make sure you send me a picture, text it, email it, Instagram, whatever it is, so I can give you credit for it. It is beautiful, beautiful weather today, kind of like the weekend, so please make sure you get outside, but stay safe, stay away from other people. Make sure you're washing your hands, and please reach out if you need anything, even if it's not related to school. Okay? All right, I will see you guys tomorrow. Bye.